My name is Jemima Masiyogwang, and this is Farm Primary School, P6 and Primary 6 and 7, presenting to you a science discussion. Let's welcome Murungi Joy to begin.
Hello everyone, my name is Murungi Joy. I've come to discuss about the circulatory system, but I'm going to majorly talk about blood. So before I start, now we have like many keywords in the circulatory system, right? So those keywords, let me put here blood. Let's talk about majorly the three: blood, heart, and even the blood vessels. So, let me define the word blood. Blood is a red liquid that continuously flows in the body of every animal. So, what is blood?
Blood is a red liquid that continuously flows in the body of an animal.
So now, can I get someone to define for me the word heart? Eric?
The heart is an organ that helps to pump blood.
Thank you. So we have now learned that the heart is an organ in the body that helps to pump blood. So now let me get someone else to define for me this word, blood vessels. Mabonga?
Blood vessels are tubes in the body that help to transport blood to all body parts.
Thank you. So now let me go and identify the systems of the body. So can I get any people who know them? So let me start with Priscilla.
Reproductive system.
Thank you. Rohi.
Skeletal system.
Samuel.
Digestive system.
Batamba. Joel. Then
Respiratory system.
Ella.
Circulatory system.
Thank you. That we are talking about. So now, let me identify the components of the circulatory system. Matthew.
Blood.
Thank you. So, Promise.
Blood vessels.
Sabi.
Heart.
So now we have learned the components. So now, let me talk about blood. Blood, it's a red liquid that flows in the human body continuously, right? Or even in any animal's body. Can I please get your attention? So now let me describe the components of blood. In the blood, we have blood vessels. Out of those blood vessels, we have red blood cells, white blood cells, blood platelets, and blood plasma. So all these are in your body. Yes, they are microorganisms. You cannot see them with your own eyes. Even if you get a cut, you cannot know that these are the red blood cells. So now, can I get any? I'm going to get individuals to tell me the use of these components of blood and how they work and help you in the body organs. So now, let me start with Morgan.
The use of red blood cells is to transport oxygenated blood around the body to all body parts.
So, yeah, let me support his answer. Red blood cells support transport oxygen to all body parts. Can I see the hands up? So, okay, Mabonga.
White blood cells help to defend the body or to help the body to fight against diseases.
Yes, let me talk about the white blood cells. How do they defend the body? We have three answers. Samali. Defend the body.
By engulfing.
Thank you. The second, okay. Later.
By releasing antitoxins.
Okay. Then, lastly, Rohi.
By producing more antibodies.
Casey.
By agglutination.
Thank you. So this all works in the body when you don't know what's happening. But now let me go to the blood platelets. How do they help you? Eric.
Blood platelets help to clot blood in the body.
Blood platelets help to clot blood in case of any bleeding. Let's say you were peeling matoke or anything, you cut yourself and then blood comes. And blood comes and starts flowing. Then these blood platelets will come and clot to stop bleeding and loss of blood. Now let me continue. What does the blood plasma do? Casey?
It is the liquid part of blood.
So how does it help in defending the body? Matthew?
It helps to transport carbon dioxide from all other parts.
Thank you. So since we have finished this now, let us go to the diseases of the circulatory system. Diseases of the circulatory system. Tabitha.
Diabetes.
Okay, thank you. Morgan.
Malaria.
Thank you. Promise.
Leukemia.
Priscilla.
Anemia.
Matthew.
HIV AIDS.
Okay. Ella.
Excuse me, Joy. Please, I can't walk from one corner to the other room very fast.
Sickle cells.
Then lastly, Rohi.
Hypertension.
Excuse me, Joy. it's hard to move.
It's okay. So now, let me welcome Joel to talk about the blood vessels. Thank you.
So, my name is Ijuka Joel. Today I want to discuss about blood vessels. What are blood vessels? Casey.
Blood vessels are tubes in the body that help to transport blood.
Correct. Now, types of blood vessels. Janan. Arteries. Azonye.
Veins.
Lastly, Jotham.
Capillary.
Correct. So we want to know the work of each of them. What are arteries? What do they carry? Eric.
Arteries carry oxygenated blood away from the heart.
Correct. So this is an illustration. Who can volunteer to draw a heart? Solomon. As you see, this is an illustration of the heart. Who can name this part? Mabonga.
Vena cava.
Wrong.
Ventricle.
Wrong. Joy.
Ota.
Correct.
Joel. Pulmonary vein.
Correct.
Joel, you have changed the what? The parts.
Oh yeah. Yeah, somehow confused. Who can name this part? Come and write. Casey.
Pulmonary artery.
I said come and write. Incorrect. Joy.
This is the vena cava.
Thank you.
So let us call somebody else to name this part. Summary.
This is the pulmonary artery.
So as you see, now we want to know what each does. Who can name what this vein does? It's a vein.
The vena cava transports the oxygenated blood from the body to the heart.
Correct? As you see, it transports. Now, as you see, even this one, there is a major word that's supposed to be mentioned that all of them do. Who can mention what this does? Joy.
It carries oxygenated blood from the lungs to the heart.
Correct. As you see, this one, even it transports. All of them have one major reason. All of them have this in their jobs. Even this one transports it to the lungs. This one transports it all over the body. Then it will come back from here. So that it will repeat like that. That's why they call it circulatory. It moves in a circular way. Which shape does circular come from? Nabil.
Circle.
Correct. As you see, a circle is like this. So even them, they move like this. All the time it will move like this, like this. It will go circulating throughout the body. Who knows what would you use if you don't have blood in the body? Tyre.
You die.
Correct. You will die. Later.
I thought you said what will we use, not what would happen if we don't have blood.
I said what will we use, so incorrect. So later, give us the answer. So Oyoma, give us the answer. Mama, let us continue. Just leave those ones. They are always confused when they are teaching. They don't pay attention. As we were still here on the heart, the arteries, what helps them to withstand pressure of oxygenated blood? Now you see, hands are few. Solomon.
Arteries have thick muscular elastic walls that enable them to withstand blood pressure.
Correct. They have thick. Solomon, please may you come and draw for us an illustration. So, who can come and name this part? This part. Matthew. Then another person come and name this part. How come girls are not raising their hands? Correct, but it's not supposed to be in plural. Then who can come and name this part? Rohi. Correct. Who can come and write the spelling of what joins these two blood vessels, a vein and an artery? Someone come and draw an illustration. The whole thing. Okay. So, who can come and name this blood vessel? Leslie. Correct. Who can come and name this part? Joy. Very wrong. Now it's time for the boys. Oyoma. Correct. Can we clap for him? Let us call letter to name this part. That part. Correct. Let us welcome Leslie.
Thank you, Joe, for what you've taught us about blood vessels. So now let me welcome Rohi to talk about
Good morning. My name is Rohi, and I'm going to talk about the disorders of the circulatory system. We have cuts, thrombosis, coronary thrombosis, and many others. Who can define for us thrombosis? Who can define for us the word thrombosis? Joy?
Thrombosis is a hard accumulation of blood in the blood vessel due to clotting of blood.
Thank you. Who can define for us the word cut? Eric?
A cut is a breaking of a skin due to an accident.
Thank you, that's correct. We also have, apart from these are the keywords in the disorders of the circulatory system. The others we have coronary thrombosis. We have heartburn. That's all, and I want to talk about how these are the disorders and how to care for them. Azonye?
By eating a balanced diet.
Correct. How should we eat a balanced diet? We have to eat proteins. Those are the things that are included in the balanced diet. We have to eat proteins, carbohydrates, vitamins, and many others. Tabitha?
By doing regular physical exercise.
Yes, when you talk about doing regular physical exercises, you have to wake up in the early morning, you run, you do push-ups, many others. Tyree?
By going for regular medical checkups.
Yes, you have to go for regular checkups to the doctor to see if you have any disease. You may go and you find when you have pressure, but you have not been getting signs. Ariella?
Avoid eating things which are too fatty.
Okay, who can give us the examples of the fatty foods? Batamba? Pork. Yes, they refuse us to eat pork because it brings diseases in our bodies. Jotham?
Chicken. Or chips.
Okay, chicken and chips are junk foods. They refuse us to eat them every time because they use cooking oil and it's too fatty. William?
Animal fats.
Yeah, animal fats. We have meat, as Batamba said, pork. They are also fatty, that when we eat them, they have a lot of oil that they use to cook them. Else. Do you have any questions? Okay, that's all I had to do. Later.
What is coronary thrombosis?
Coronary thrombosis is the hard accumulation, as Joy said. It's the same as thrombosis. Joel?
Where does coronary thrombosis occur?
You ask the teacher who teaches you. Arafat?
What does coronary mean?
Coronary, you go research by yourself. That's all I had to say.
Thank you, Joy, Joel, and Rohi for that presentation. Let's welcome Difas.
Good morning, everyone. As we are talking about the circulatory system, I was supposed to come here before, but I was be among the first people because I was talk about the heart, how the blood flows, and some parts of the heart. So, as I'm going to draw the heart, as you wait and see.
First talk about the dot, the words.
here I want to correct what Joy said. The keyword she said, she was speaking about components of the circulatory system. Who can say one of the keywords? Keywords of the circulatory system. Solomon? System. Now, who can define what a system is? Because we have learnt about it. Morgan?
A system is a group of organs that work together to perform a particular function.
Correct. Now, as we want to speak about the heart, they said one definition, but who knows the best definition? Oyoma?
The heart is an organ in the body that pumps blood to all parts of the body.
Not what I wanted. Eric?
The heart is a muscular organ that pumps blood in the body.
Correct. So now we want to define what circulatory is. As I said, what's circulatory? Oyoma?
This is the flow of blood around the body.
Not correct. Morgan?
Circulatory is the movement of blood around the body.
Not correct. Eric?
Circulatory is the movement of blood in a circular form.
Correct. That's all I had to say.
It's back to the heart, as I was still drawing the heart. So now, this like just a structure like the heart, not that really. So we are going to start naming the parts. So now I would like to ask, first of all, what is this blood vessel called, this one? What is it called? Yes, William?
I'm not so sure, but vena cava.
Yes, Oyoma. Yes, Matthew?
Vena cava.
No, please. Yes, Tyree.
I'm not so sure.
Okay, what type of blood vessel is it? Yes, Leslie.
A vein.
Yes, it's a vein. This is a vein. Then what about this one? Yes. Yes, Samuel.
Atari.
No, please. Yes, Eric. Yes, I want to use white paper. Yes, please.
It's an artery.
No. Yes, Janan.
Blood vessel.
No. Yes, Arafat.
Pulmonary artery.
No. Yes, Morgan.
A vein.
Yes, it's also a vein. When you draw the heart, the two downer blood vessels. This one and this one are the veins. Then these two are the arteries. When we are going to name, you're going to find out that they are veins. So now what's this blood vessel called? Yes, Bright.
Pulmonary vein.
No, please. Yes. Yes, Priscilla.
I'm not so sure.
Yes, Nawide.
Pulmonary artery.
No, please.
Vena cava.
It's the vena cava. So this one is the vena cava. So this is the vena cava. Then, what about this one? Yes, Eric.
Pulmonary vein.
No. Yes, Solomon.
Pulmonary artery.
Yes, this is a pulmonary artery. So now, as you can see now, the structures. This is the vein. This is the artery. So now we are continuing. How about this one? Yes, Samali.
Aorta.
Aorta. This is the aorta. Then the final one. A girl. Girl. A girl. Daphne.
Pulmonary. Pulmonary vein.
Yeah, this is the pulmonary vein. So now, let's now go back to the first question I was asking. I asked you what type of blood vessel was this. Now you can find out this is a vein. This one, it's a vein. This is a vein. Even this one, it's a vein. Have you seen? So the down ones are veins. Then these are artery. This one's an artery. Even this one's an artery. Have you found out? Now the two above are arteries, then the ones below are veins. So now we are going to go to the movement of blood. How does blood move through this heart? Before I go there, let me first name some parts. Allow me ask, how is this part called? This one and this. How are they called? This one. Yes, Samuel.
I'm not sure.
Mabonga.
Valve.
This is a valve. This is a valve, but what's the function of that valve? Yes, Alamo.
I don't know.
William.
A valve is a structure found in a vein that closes or opens.
No, thank you. Yes, Tyree.
Prevents blood from flowing back into the artery.
Yes. Prevents the backflow of blood. Have you heard? Prevents the backflow of blood. So in all veins, valves are present. What? There's one valve, of course, here. Every vein has a valve. So now let's continue. How is this part called? Yes, Priscilla.
Septum.
Septum. That's a septum. Matthew, what's the function of the septum?
To separate the left chamber and right chamber.
Yes. Another function, Leslie?
To prevent oxygenated blood from mixing with deoxygenated blood.
Yeah, it prevents oxygenated blood from mixing with deoxygenated blood. We are coming to that. Then finally, let me maybe name this part. What are these called? What are those called? Yes, Ariella.
I don't know.
Joy?
Cardiac muscles.
Cardiac muscles. These are the cardiac muscles. So these are the cardiac muscles. Now we are going to the flow of blood. Let's first identify the blood. Which blood is found in this right chamber? Which blood is found in the right chamber? Which blood is found in the right chamber? Yes, Casey.
Deoxygenated blood.
Yes, this deoxygenated blood from here that flows, all the blood that flows from here into the vena cava. All this chamber has deoxygenated blood, all here. This all deoxygenated blood. So when blood enters through the vena cava, that deoxygenated blood, where does it go to? Where does it go to and where does it pass through? Where does it go to and where does it pass through? Yes, Bright. Yes, Oyoma.
It passes through the pulmonary artery and enters the lungs.
Yes, it comes from here. When this blood comes from here, it enters, it continues, then here it now goes this side up, going through the pulmonary artery to the lungs. Then why does it go to the lungs? Why does it go to the lungs? Yes, Mabonga.
To drop carbon dioxide and pick up oxygen.
To drop carbon dioxide and pick up oxygen, isn't it? Why does it drop carbon dioxide and pick up oxygen? Why is it taken there to drop carbon dioxide and pick up oxygen? Why? 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 Why does it go to the lungs to drop carbon dioxide and pick up oxygen? Yes, Casey.
The body does not use carbon dioxide and it's exhaled out of the lungs.
Yes, it doesn't use, but why does the blood go to the lungs to drop carbon dioxide and pick up oxygen? Yes, Oyoma.
Transport oxygen to all parts of the body.
Yes, I know that much. Yes, Morgan.
Carbon dioxide does not support the body.
No, thank you.
To allow oxygenation to take place.
Oxygenation, no. Who was the answer? Yes, Mabonga.
To allow the blood to become oxygenated and be transported to all parts of the body.
Okay, it's almost the answer, but okay, in fact, it's almost the answer. I asked, why does the blood drop carbon dioxide and pick oxygen? Simply to be turned into oxygenated blood. That's the answer. Because when it drops carbon dioxide and picks oxygen, it now becomes oxygenated blood. Have you seen? So through the respiration, when you breathe in oxygen, that oxygen that turns the oxygenated blood into oxygenated blood. Now the carbon dioxide is exhaled out. So the question was simple, but it looked hard. So now let's continue. When it comes from the lungs, with us oxygenated blood, it will passes through. Yes, Azonye, passes through.
Pulmonary vein.
Yes, passes through the pulmonary vein. So when the blood enters through here. Now that blood is deoxygenated. No, it's oxygenated. So now here it comes oxygenated blood. All over here is oxygenated blood. I hope you can see the difference. Here is oxygenated blood. But what's the difference between deoxygenated blood and oxygenated blood? Yes, Joel.
Oxygenated blood is light red while deoxygenated blood is dark red.
Yeah, it's light red. It's not that dark. Like if you have ever seen blood that's very dark, that's how deoxygenated blood looks like. But oxygenated is light blood. Like when you cut your body, most of you see that blood light red. If for yours is dark, I don't think you use oxygen. So now here is oxygenated blood that enters through the pulmonary vein, passing through the valves. So when it enters here, it has to go back like this. So now these valves, they will not allow it to go back like this. When the blood comes back, the valves close. Have you seen? This valve, when the blood comes back like this, it will enter, of course. Then when it reaches here, it turns going up. So going up. In case the blood comes back here, the valves close to prevent the blood from going back. So now when that blood enters here, it goes where? Where does it go? Yes, Lisa?
Goes to the aorta.
Yes, goes to the aorta, yes. To come, of course, the aorta. So now when it reaches, where will it go when it comes to the aorta? Where to? Yes, Sarah?
The body.
To the body. It now moves the body from the aorta, it comes to the body. To come back to the body. So now, as you see the movement, the blood, this deoxygenated blood that enters through the vena cava, it's deoxygenated. All this deoxygenated blood. This deoxygenated blood, it was first brought from the body. From the body, it was brought the lung to the heart. Why is it brought the heart now? Why was this blood brought the heart? Why was the blood brought the heart? Yes?
So that the pump, so that the heart can pump the blood to the lungs.
Yes, it can be pumped the lungs. Now, why does the heart pump it the lungs? Yes, Ariella?
Don't know. To tramp.
Yes, Rohi?
I'm not sure.
Jotham?
I'm trying to transfer oxygen.
Yes, Tabitha?
I'm not sure.
Promise?
I'm not sure.
Yes?
To drop carbon dioxide and pick oxygen.
Yes, now I even mentioned before to drop carbon dioxide and pick up oxygen. So when it goes to the lungs, it drops carbon dioxide. When it's deoxygenated, it contains much of carbon dioxide. The blood contains much of carbon dioxide, little oxygen, sometimes no oxygen. It's contained. So now the heart has to pump it to the lungs, drop carbon dioxide and pick up oxygen. So now when that oxygen is picked up, the blood is being transferred back to the heart So when it comes back to the heart, it enters through the pulmonary vein. And when it enters through the pulmonary vein, it comes, and again, it's supposed to be pumped back to the body. And the heart has to pump it back to the body. So now, it's pumped through the aorta back to the body. Then, if the oxygenated blood is pumped back to the body, why is it again pumped back to the heart? That's the question. If oxygenated blood is pumped to the body, why is that blood again pumped to the heart? Yes, Oyoma?
To be pumped to all parts of the body.
No, the heart has pumped it to the body. Now, why is it again transported to the heart? Yes, Joy?
To be taken to the lungs for oxygenation.
The blood was pumped, oxygenated blood. Okay, the blood was transported from the lungs to the heart, oxygenated blood. Then the heart pumps that oxygenated blood to the body. Why is it again transported to the heart? Yes, Morgan?
Because all the body parts use oxygen.
So when all the body parts use oxygen, again they transport the blood to the heart. Anybody else? Yes, Casey?
To complete the circulatory system.
To complete, not that much. Yes, Oyoma?
To be sent back to the lungs to be oxygenated.
Not that much. Because oxygenated blood is being pumped from the heart to the body. Why is that blood again taken back to the heart? Yes, Mabonga?
Because the body parts use more oxygen and bring little carbon dioxide to the heart.
Not that much. Last person. Who's taking the last chance? A girl now. A girl. The question was, from the lungs, oxygenated blood is transported to the heart through the pulmonary vein. It comes in the heart, then it's pumped the body. If that oxygenated blood is pumped the body, why is it again transferred back to the earth? Why is it transferred the heart? Oxygenated blood is pumped the body. Then why is it transferred the heart again? Oxygenated blood is pumped the body. Why is it transferred the heart again? Sit down. Okay, my final person is Leslie.
The body has used all the oxygen in the blood, so the blood comes back to the heart to drop carbon dioxide and pick oxygen.
Yes, that's the answer. Because if the heart pumps oxygenated blood the body uses that blood. Now the oxygen gets used up. Now the body has again transfer. The vena cava has again transfer it to the heart to drop the carbon dioxide and pick oxygen. It moves in a circulatory way. This is what it's called the circulatory system. It's a circular movement. When it comes to the body, again transferred back to the heart, the lungs back to the heart, and again the body. So when that oxygenated blood is transferred in the body uses that oxygen. When the oxygen is used up, it's again taken back to the heart. Have you seen? It's like when you go eat food, when you're hungry again, you go back to the dining hall to eat food. So you're also like in a circular movement. You do your things in a circular way. When you want food, you go to the dining hall. You come back. Again, when you want, you go back there. Have you seen? So that's how the heart works. So then these muscles, who can tell me the difference between this part and this one? The difference between these are cardiac muscles. All these cardiac muscles. But what difference do you see in them? What difference? What difference do you see? Yes, Sarah. What difference do you see between these cardiac muscles here at the left chamber and at the right? They're bigger than others. They're bigger than others? No. Anyone else? Girls are now, what's wrong? Boredom, what? Yes, Samali.
The left side has more cardiac muscles than the right side.
Yeah, it has more. They are thick. More cardiac muscles. Why does it have more? Why? They all have to have them, but why does this side have more? Why? Yes, now with Yes, Janan.
It has to transport oxygenated blood to cover a short distance. What?
No, thank you. Yes, Priscilla.
The ones on the left-hand side have to be bigger because they transport blood a further distance than the ones on the right-hand side.
They transport blood
a further distance.
They transport the cardiac muscles. What they do? Yes, Joy.
To pump blood at a higher pressure because to pump oxygenated blood at a higher pressure because it has to go a long journey than the rest.
They are thick because they have to pump blood at a high pressure to long distances. So like now, the oxygenated blood is supposed to be pumped to all body parts. So they are thick to pump that blood to all body parts. And that's a far distance. Like from your chest, the blood is supposed to be pumped to the toe. Have you seen? To the head, where the brain, the blood is supposed to be pumped there. So now that's why these muscles are thick. So, any question? Yes, Morgan.
How many times does a heart pump in 1 minute?
It pumps like in a minute. Takes like 60 to 100 beats in a minute. From 60 to 100 beats in a minute. In an adult, that's in an adult. 60 to 100 beats per minute. Yes?
What is the use of, what happens if blood moves backwards?
It can't flow backwards because there are valves. It can't. There are valves. Yes, Joel.
Why are the muscles on the left chamber stronger than the ones on the right chamber?
I've just answered that question now. The muscles in the left chamber, they pump blood at the high rate to long distances. Last question. Last question. Any question? Yes, Matthew.
Why doesn't the deoxygenated blood go to all other body parts?
Oxygenated blood?
Deoxygenated
blood. Why does it go to other body parts? No, deoxygenated blood doesn't go to all other body parts because from the body, oxygenated blood is used. Then when the oxygen is used up, that blood becomes deoxygenated blood. In all other body parts, when the oxygen is used, becomes deoxygenated blood. So now the vena cava has this vein has to transport that deoxygenated blood from the body parts, collect it to the heart. Now from the heart, it's taken to the lungs, and it's again it drops carbon dioxide and picks oxygen, making it oxygenated blood. Then it's transferred back to the body. So it can't be transported in the body when it's deoxygenated blood. It's instead transported from the body to the heart. Okay, last question.
Excuse me, D first. My teacher told me that the heart pumps 72 times in a normal human being, but You said it pumps 60 to 100 times.
Yeah, according to the textbook I read, it said that 60 to 100 beats per minute in an adult. So I'm not sure of the young children, the infants. I'm not so sure, but according to the textbook I read, it said that from 60 beats to 100 per minute in an adult. Yes? I'm not so sure of the young child. So I hope that's the last question. Let me welcome Jemima.
Thank you for that presentation, DFAS. Let's welcome Leslie.
Hello, everyone. I'm going to talk about the circulatory system, but I'm mainly going to talk about diseases. Who can give me diseases of the circulatory system? Azonye?
Sickle cell anemia.
What causes sickle cell anemia? Anyone? Okay, sickle cell anemia is caused by when a germ later.
This is when not red blood cells turn into a sickle.
Let's clap him.
In a sickle shape.
Another disease? Right?
Leukemia.
Please can you help me with spelling of leukemia? Okay. What causes leukemia? Janan?
When there are too many white body cells in the body.
Let me correct that statement. When there are too many premature white blood cells in the body, and they rot. Another disease? Jemima?
Malaria.
Name any one way of preventing malaria. Joy?
Sleeping uneducated mosquito net.
Ariella?
HIV/AIDS.
I was asking ways of preventing malaria. Later.
Slashing bushes around on the compound and around it.
Promise.
By draining stagnant water.
Correct. Terry?
Using mosquito repellents.
Thank you. William?
Taking anti-malaria pills.
Can you come and spell that word? Right on the chalkboard. Are you sure or not? You're not sure. So like, another disease? Morgan?
HIV/AIDS.
Anyone else? Oyoma?
Diabetes.
And many others. So today I'm mainly going to talk about HIV. What's HIV in full? Tabitha?
Human immunodeficiency virus.
And what is AIDS in full? Joy?
Acquired immunodeficiency syndrome.
So, HIV. HIV is a virus. A virus, okay, ways of contracting HIV. Or ways of getting HIV. Sheila?
Through blood transfusion with an infected person.
Samari?
Having unprotected sex with an infected person.
Janan?
Through sharing sharp objects with an infected person.
Sharp skin piercing objects. Anyone else? Rohi?
Through transfusion of unscreened blood.
Already mentioned. Azonia?
Through some cultural practices such as circumcision.
Circumcision using a blade which was used on an infected person without being sterilized. So, acquired immunodeficiency syndrome. What does it mean according to your understanding? What does it mean to you? Okay, so HIV is a virus. You've already mentioned how we get it. So, HIV causes this. Why is it hard to eliminate HIV in a human body? Morgan?
It's a strong germ.
Incorrect. Janan?
It weakens the white body cells.
You're close to the answer, but not correct. Priscilla?
The HIV can camouflage itself by turning into a white blood cell.
Let's clap her. That's correct. Because until now, the vaccine for this disease is not discovered because due to the fact that it replicates itself, so people think it's also a white blood cell, so it can't be destroyed because then we'll have to destroy the white blood cells, which this virus does. It destroys the white blood cells, and when the white blood cells are destroyed, it paves the way for other diseases. And without white blood cells, they can't fight diseases. So that's what AIDS is trying to, like, that's what it means. So AIDS is like other diseases which people get in the body from HIV. So these two are not like the same things. They are two different things. This one comes first, then this one comes second. So who can define for me the word deficiency? Morgan?
Deficiency is a lack of, I don't know.
Joy?
Deficiency is a lack of a food value in the body.
Thank you. Anyone else? Matthew? So I guess that's all I had to say. Let's welcome Oyoma. Let's welcome Jemima.
Thank you for that speech, Leslie. Let's welcome Oyoma. Let's welcome Oyoma to finish.
So I'm going to talk about the components of blood, I'm going to talk about the components of blood and their uses. We have the platelets, which are also made of the red bone marrow, and they clot blood. They do not have a nucleus.
Excuse me, Oyoma. What's a nucleus?
It's like the brain of the organ. Who can tell me another name of the platelets?
Thrombocytes.
Let's clap for him. Next, we have the blood plasma. Who knows what the blood plasma is? Joy?
Blood plasma is the liquid part of blood.
Correct. Do you know what it does? Matthew?
It helps to transport carbon dioxide from all other body parts.
Correct. Let's talk now about the white blood cells. Do you know the uses of the white blood cells? Eric? Later. Okay, Eric?
White blood cells fight against disease-causing germs.
Correct. And do they also have a nucleus?
Yes.
Who can tell me the work of the nucleus in the white blood cell? Janan? Jotham?
No idea. May you please give it to Morgan?
Morgan?
To control all the body parts.
Correct. Next, we have the red blood cells, which are also disc-shaped. They're in a shape of a disc. And they also do not have a nucleus. And the work of the red blood cells is, Eric?
Transport oxygen in the body.
Correct. Thank you. They are also made of the short bone marrow, red short bone marrow. And this bone marrow is got from the short bones. Thank you.
Time to continue off where he left on red blood cells. This is the front view of a red blood cell when you see it from the front, and this is the side view when you see it from the side. Red blood cells are formed from the bone marrow of short bones. Examples of short bones? Eric?
Steps.
Yes. Another example? Morgan?
Fingers.
That's incorrect. Matthew?
Cartilages.
Negative. Eric?
Stirrups.
Yes. Or the metatarsals and the metacarpals. I'm going to talk about a disease that affects the red blood cells. That's sickle cells. We all know sickle cells, right? Yes. Sickle cells, when it affects sickle cells, the sickle cell germ, when it sees a red blood cell like this, it doesn't think it's okay. So what a sickle cell germ wants is a red blood cell like this. That's why it gets the name sickle. You know what a sickle is? A sickle is used for harvesting. A sickle is somehow shaped like this. Yes? Oh, it's also shaped like a half moon. So this disease, it destroys part of the red blood cell. And when the red blood cell is as small as this, first of all, what's the use of a red blood cell? Or what's the use of red blood cells? Morgan?
To transport oxygen to all body parts.
Yes, that's the main function. So when the red blood cell is this size or as small as this, it can't transport enough oxygen. The oxygen will be inadequate. I believe we all understand the word inadequate. Inadequate means little, small, not enough, few, yes, less. So, next up, I want to talk a little bit about white blood cells. White blood cells are in irregular shape. We all understand what we mean irregular shape, right? An irregular shape is the form of a white blood cell. If they ask you for a simple diagram of a white blood cell, you can simply draw anything. Just move the pen a little around, and then you put a circle in the middle and lines. This will be considered the red blood cell, white blood cell. As long as the shape is not definite. We all understand what we call definite. By definite, the shape is regular, like a square. This is accurate, right? Okay, it has shape. At least we can know that this is a square, right? Something with an regular shape. But it has this irregular body shape in order to easily engulf germs. By engulf, it covers. Like, this is a white blood cell, and this is a germ. So, this is step one. This is the first step. Second step, it starts preparing. It starts forming like a mouth-like structure to engulf the germ. Yes. It keeps on engulfing until it fully encloses the germ. Would you want to see a practical? May I have 4 people in front? Morgan. Okay, 1, 2, 3, 4. Okay? No, that's enough. I want you to hold hands, 3 of you, and this is a germ. You're going to come and cover the jam. Ariella, stand here. You are a jam. Okay, Eldad, you are the jam. So let's see how this works. Start. Engulf the jam. Like that. They come and squeeze the jam. They engulf it, then the white blood cell digests it. Have we understood? May we clap for them as they leave? That was a simple display. I'm now going to look at the disorders of white blood cells. The number one, yes, Joel?
Thrombosis.
Thrombosis. Eric?
Another name. Leukocyte.
The answer is leukemia. Can we all say leukemia? What? Leukemia. Can we have anybody to come up and spell the word leukemia? Eric? Yes?
L.
L.
E.
E.
U.
U.
K.
K.
E. A.
E.
A.
A.
S. No.
Is it correct? Yes, Janan.
LEU KA MIA.
Is this correct? What's wrong? Yes, all dad.
There is no C. They need to replace letter K with C.
No. Joy?
Leukemia. LEUKAEA. E before A. MIA.
Where did you get this from? Okay, let's just leave that spelling alone. You'll go and research.
That's right.
Jotham. Jotham.
Excuse me, William.
Yes.
Some people are not ready for that spelling, so its other name is blood cancer.
Okay, let's just keep it simple. Blood cancer. Blood what? So blood cancer is a disease that affects the white blood cells. White blood cells. It affects the white blood cells number. Like it leads to either increase or decrease, but most of the time it's an increase in the production of the white blood cells. We all know the saying that too much of anything is what? Too much of anything is bad. Yes? But too much of anything is bad. When something is many, it can lead to a downfall. Yes, Morgan?
What about too much of water? It's bad.
What?
It can kill you, man. If you drink too much, it will start accumulating and then it will come.
There's no water. I'm summarizing. What? I see a hand by Matthew.
Matthew.
Yes? You are raising your hand. Okay. Leukemia is the improper growth or improper number. Leukemia is simply when the white blood cells are produced more than usual. Like, let's say if in 1 tablespoon of blood, there are supposed to be 1 million 1 million white blood cells. But suddenly you find them to be 3 million. This is an abomination and it's not accepted. This disease, with the research I made, stated that it's hereditary. We all know what hereditary diseases are. These are diseases we get from our ancestors. Diseases we get from our ancestors. The cure for leukemia is not yet found. And for those of you who have or have patients with leukemia, they should be taken care of very well. Because since the white blood cells are in many number, some of them just die off and rot in the body. So at the end of it all, I have to come to an end. May I welcome the MC? Questions? May I welcome questions?
How can we care for leukemia?
Leukemia? Feed the patient on time, take them to the clinic. Morgan?
Are there any signs of leukemia?
Yes. Can be body weakness. Can be body weakness. When someone gets a disease, it takes time to be cured. Yes, stuff like that. Well, my discussion has come to an end. May I welcome the
Thank you, Oyoma and William, for that discussion. It has come to an end of our presentation. Let's welcome Joy.
Hello to all the viewers watching us online who are live right now. Thank you for watching and thank you for staying and thank you for supporting us as Farm Fund. And those who are in the community and you know your child is not in Farm Fund, please, you're welcome to bring your child to Farm Fund. It's a very good school. You learn a lot. And through these discussions, a child learns more than the way they learn in class. Thank you.
Thank you, everybody. Thank you, everybody. Discussion. Yeah, man. Yeah. Dun, dun.
Maybe you can just end it.
Teacher, Mr. Dennis was there.
Dad, go away.
First bring.
Thank you for watching. Be blessed as you spend. May God bless you.
The microphones are still on, man.